Immediately we go to our third presenter, Esther Magondu. Kindly, if you're there, just you can start your presentation. Kindly, Esther.
Hello, everyone. Good morning.
Hello, Esther. Good morning. Kindly, let's keep time, 10 minutes.
Let me share the screen. I hope I'll manage from my side. Okay. You can see it?
Yes, we can see it. Maybe just have it in presentation mode.
Okay. It's now in presentation mode?
Yes, yes.
Okay, thank you. Welcome everyone to this presentation. My name is Esther Wairimo, and it's a short presentation of some progress of some work that I've been doing. So I work with Kenya Marine Fisheries Research Institute, Mombasa, and I'm also a student at Pwani University. I'm undertaking my studies, my PhD studies. So I'll be presenting to you a study on aquaculture this round. We are doing, the title is towards recruitment of sea cucumber and cockles in an integrated culture with shrimps in earthen ponds in Kibokoni around Kilifi Creek in Kenya. So the outline of my presentation will be that I'll start with the introduction, then research objectives, the design, the results that we have achieved, the discussions, the challenges, and finally the acknowledgement. So first, I'll start with a brief introduction, or rather the background of this study. We realize that in aquaculture, the growth is going on an upward trend, according to those recent authors, and the driving force has been the demand of seafood products that is already global. So the effects to these are threats to the ecosystem due to the precautionary use of inputs that we are putting into the culture system, that is fish feeds, we have fertilizers, sometimes antibiotics when we are rearing these organisms. And the possible remedy to this situation is the concept of integrated multi-trophic aquaculture, which I'll focus on in this presentation, which has environmental, economic, and also social benefits. So towards my right side, there is a small figure there. It's actually the concept for maybe some few of us who doesn't understand the IMTA concept. The figure tries to explain about it as part of this introduction. So in an IMTA concept, we have a fed component. Like in this picture, you can see we have finfish that are fed feed. So that is the fed component of the system. Then we have an extractive component of the system. We have, like in this case, we have seaweeds, which take up the phosphorus and nitrogen from the system. We have deposit feeders, that is the sea cucumber, which clean the system, or they take up the organic matter from the system. And we have suspension feeders like the cockles or the shellfishes, which take up the suspension, the suspended particulate matter from the system. And with that cleaning, what you expect to derive more benefits, or more benefits from the system when you catch a fish in such a system. So the statement of this problem of this, the statement problem of this study is because of raw catcher fisheries, which has led to overexploitation. So that is an existing problem. There's population increase, hence there's rising per capita fish consumption. And then there's, because of questionable aquaculture management practices, which have compromised production, then that's why we looked at doing this particular work. So to my objectives, the overall objectives of this study is to introduce an IMTA system, which I've referred to integrated multi-trophic aquaculture system for the culture of marine organisms in order to enhance overall production, profitability in small mariculture enterprises here in Kenya. So, but in this study, we focused mainly on the marine environment or marine aquaculture. So the specific objectives were to determine the viability of integrating an IMTA of sea cucumber. Those are the organisms that are used in this study, cockles and also marine shrimps. And the particular shrimps are used is the Pineas indicas. We also wanted to assess the potential profitability of the IMTA system in comparison with monoculture system in earthen ponds. And we also compared the differences in physical-chemical parameters of an IMTA system versus a monoculture system. So this map shows where the study or the study area of where this work was done. So these are where the red arrow is pointing, those are intertidal ponds along the Kilifi Creek, where there's a mariculture group that is doing some farming of different organisms. So we did set our experiment there. So and then we had a design where we had 2 treatments with 3 replicates. And we used a total number of 6 ponds where we did the replication. The first 3 we used the IMTA system, and the other 3 we used the monoculture system. So in the first treatment we had the Pineus indicus, as I've said, and then the other treatment we had the combination of Pineus indicus, the sea cucumber, which is the particular species was Horodurius cabra, and then the cockles, and the particular species was Anadara antiquata. So and then we did, of course, the data analysis, which we used different tests as I've indicated there. So going forward is just some photos to show the experimental organisms, maybe for somebody who might not be aware of how they look like. So we have the Pineus indicus, as you can see there. This is actually where we did this study. The farmers there have just been producing and have been doing monoculture of this study using this particular species. So then we have what we introduced, the cockles, and then the sea cucumbers. So going to the results, we did. After the study, we collected data. After the capture days, as I've indicated, we did capture the organisms for 135 days. So you can see from the first graph, the weight versus the capture days. As you can see, the growth we got from Horodurius cabra, it did very well, and then which was followed by Anadara antiquata, and finally the Pineus indicus. Versus now the monoculture, where we still the same experimental period, and also the growth, as you can see, or the weight achieved, as you can see from that graph. Then the yield, I have a table showing the growth and yield parameters that were studied or that were collected from when we were carrying out the experiments. Both treatments. So treatment 1 was the monoculture of the Pineus indicus, as you can see from that table, and then treatment 2, it was the IMTA, which shows the different parameters, the stocking densities, the stocking weight and the harvest weight, the average fed component, average apparent feed conversion ratios, which I calculated only for Pineus indicus, because those were only the fed component of the system. That's why we are missing the 2 from the H cabra and the Anadara antiquata. Then we had the individual net weight gain, the daily growth rate, and also the specific growth rate, and then the survival. And here I would like to mention, you can see the survival for H star for the sea cucumber was quite low as compared to the other organisms. It's because of we experienced some predation from mud crabs that were predating on the sea cucumber, so that's why the survival was quite low, as you can see. And also finally we calculate treatments. So on the far right, you can see the different organisms at harvest. So those were the sizes at harvest, as also shown in the table. So also during the experimental period, we carried out the physical chemical parameters of the culture water in both treatments. We did analysis we corrected the in situ parameters, as you can see, the DO, the temperature, the transparency, salinity, the pH, and also the nutrients. And this we compared for both treatments, and also for the different time periods, for the different times that we did the collection of the samples. And this we had to use repeated measures ANOVA, so that we can get to know the difference at different times, what was happening in the different treatments at different times. So when we went further, we went ahead and did an economic comparison, so that at least we could get a picture of how the performance was from the different treatments, and also a way of advising the farmers from this kind of small experiment we did. So for the first monoculture treatment, you can see we got a cost-benefit ratio. The net income was negative, so the performance was not very good, and also the cost-benefit ratio was 0.27 in US dollars, and the total income also the net income in US dollars also for treatment 2 was quite high because it was 516 USD, and then they performed so well with the cost benefit ratio of 1.77. So that's how the two treatments performed. So we could say from here we derived that the IMTA treatment performed better, of course, because it had quite a number of combinations. Then on discussing this briefly, so we discussed that a comparative performance analysis between the two treatments portrayed the feasibility of farming shrimps and the sandfishes together in raw-fed brackish ecosystems. The IMTA model, which performed better than the monoculture, and this concurred with some recent studies from these two others, as shown there. Then shrimps recorded similar results for growth in both treatments, so there was not much difference. Then sea cucumbers in the IMTA treatment grew bigger and faster with a specific growth rate of 4.1% and a net weight gain of 175 grams in the 135 days of catch-up period that we did this experiment. Then the policy action, now I was trying to relate this to the theme of this conference. So because of the in Kenya, there have been over-exploitation of sea cucumber fishery, which has created alarm and of course a worldwide management concern, which the main reasons have been the species is high value, there's serial local depletion, and fishermen are migrating also to new areas to try and get these species. So policies have been developed that has led to these species being listed. It's actually listed as an endangered species in the IUCN, and also other revisions have listed other species like the Horodurian obelis and also the Horodurian foscogilva. And also we indicate here that management alone cannot sufficiently overcome the issue of declining population, hence the need to initiate sea cucumber farming. So besides having this organism in our IMTA setup, we were trying, because in Kenya we have not yet started capturing sea cucumber, so it was a way of trying to see if sea cucumber can be really grown in a closed environment, or how it can perform in pond environment. And actually from these results we are able now to go on with this kind of research. So conclusions, the conclusion of this study is that the findings exhibit that IMTA involving marine shrimps as fed species with cockles and sea cucumber as extractive organisms, they performed better than monoculture in terms of production, as you saw, and also economic returns were better, and also the water quality. So the results indicate the potential viability of IMTA as a raw intensive culture system that can be adopted by coastal farmers in the region. Because the only challenge was getting the seed, because we had to rely on wild seed. But once the seed is put in the pond, like for the sea cucumber, you don't need any feeding, because they feed on the organic substances in the bottom of the pond. So actually for the farmers, that is a plus, because they'll not incur so much cost, as well as the cockles, they'll feed from the system. The only issue of the input that we put in the system is only the feeding for the fed organism. In this case, it was the Pineas indicas or the shrimps. So it's something that can be adopted easily by farmers. So we recommend further research on longer capture periods and with different species combinations with commercial value, which need to be explored to assess suitability for capture and application in IMTA systems. So, and also need for government support in terms of capital and policies directed towards domestication and capture of the species for sustainability, I think.
Thank you very much, Esther, for that wonderful presentation on the IMTA aquaculture model.
At this juncture, I just want to acknowledge the contributors to this study. The study was funded by Kenya Climate Smart. Thank you for listening.
Thank you very much. Any short questions for Esther? I know we've run out of time, but maybe 1-2 short questions.
Yeah, sorry.
Any short questions? Okay, mine will just be maybe as an additional pointer, because I know in Kenya, mariculture has not really gained traction. compared to aquaculture. So maybe when policymakers and scientists like yourself, myself and others, come up with a management plan for the mariculture sector, I think this is one of the things that could be recommended, because it seems to be feasible and could help also in the livelihoods of people, and because it's a high valued commodity, the sea cucumber, also help in the exports and revenue generation.
Yeah, sure. Thank you.
You're welcome.